subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we learn about the problems of continuity. This problem as compared to previous problem is quite difficult. In this question, the given function is continuous at x equal to 0 and we have to find the three unknown value, that is a, b and c. The question is determine the values of a, b, c for which the function defined by f of x is equal to sine of a plus 1 into x plus sine x whole thing divided by x comma x less than 0 is equal to c comma x equal to 0 and is equal to x plus bx square whole bracket raised 1 by 2 minus x raised 1 by 2 and whole thing divided by b into x raised 1 by 2 comma x greater than 0 is continuous at x equal to 0. Now let's see the solution. First of all, given f of x is continuous at x equal to 0. Therefore, by using definition of continuity, we have limit x tends to 0 plus f of x is equal to limit x tends to 0 minus f of x is equal to f of 0. Now, x tends to 0 plus means x greater than 0. That is called right hand limit. X tends to 0 minus, it means x less than 0. That is called left hand limit. And f of 0, it means x equal to 0. So therefore, the next step will be limit x tends to 0. Now, for x greater than 0, we have f of x is equal to x plus bx square whole bracket raised 1 by 2 minus x raised 1 by 2 whole thing divided by b into x raised 1 by 2.
सर तुम्ही जे सांगता ना आता प्रीवियस पेजवर पूर्ण सर त्याच्यावर ठेवा
पूर्ण
हा म्हणजे कसं
असं
प्रॉपर दिसेल नाहीतर अर्ध्या ह्याच्यावर पाकड होईल पूर्ण ठेवून ते सांगा
पूर्ण पेज ठेवू आदल्या पेजवर
हा मग ते सांगा जे सांगायचं
ठीक आहे
स्टार्ट.
So limit x tends to 0.
सर पेज
पेज बाजूला घेते
ठीक आहे स्टार्ट.
Therefore, limit x tends to 0. Now, x greater than 0, we must have f of x is equal to x plus bx square whole bracket raised 1 by 2 then minus x raised 1 by 2 whole thing divided by b into x raised 1 by 2. that equal to. Now for x less than 0, we have f of x is equal to sine of a plus 1 into x plus sine x whole thing divided by x. Is equal to, now x equal to 0. For x equal to 0, we have f of x is equal to c. Therefore, the next step will be limit x tends to 0, we write as it is. Then from bracket we take x common. So it means we get x in bracket 1 plus bx whole bracket raise 1 by 2, then minus x raise 1 by 2 upon b into x raise 1 by 2 we write as it is. Now that equal to limit x tends to 0. Now here we write sine of a plus 1 into x plus sine x whole thing divided by x, and that equal to we write c. On simplifying, we get limit x tends to 0, x raised 1 by 2 into 1 plus bx whole bracket raise 1 by 2 minus x raised 1 by 2 upon b into x raised 1 by 2, that equal to limit x tends to 0 sine of a plus 1 into x upon a plus 1 into x into a plus 1 plus limit x tends to 0 sine of x upon x, and that equal to c. Therefore, here we take x raised 1 by 2 common from numerator. So we have limit x tends to 0 x raised 1 by 2 in bracket we left with 1 plus bx raised 1 by 2. So that we write square root of 1 plus bx, then minus 1 whole thing divided by b into x raised 1 by 2, that equal to, now limit x tends to 0 sine of a plus 1 into x upon a plus 1 into x, so that gives 1 into, in bracket we have a plus 1 plus, now limit x tends to 0 sine of x upon x, so that gives 1 and is equal to c. In the first limit we cancel x raised half from numerator and denominator. Therefore the next step will be limit x tends to 0 square root of 1 plus bx minus 1 upon b, and that equal to, now 1 into a plus 1, that gives a plus 1, and again we have plus 1, so we totally get a plus 2 equal to C. On rationalizing numerator, in a first limit we have limit x tends to 0 square root of 1 plus bx minus 1 in one bracket, then square root of 1 plus bx plus 1 in second bracket, and then totally divide by b into square root of 1 plus bx plus 1 is equal to a plus 2 is equal to c. We write as it is. Now in numerator we have the formula a plus b into a minus b, which gives a square minus b square. So therefore in present case we have limit x tends to 0 square root of 1 plus bx the whole square minus square root of 1 in the numerator upon b into square root of 1 plus bx plus 1 in the denominator, and that equal to a plus 2 and is equal to c. So therefore x tends to 0, square and root cancel, so we left with 1 plus bx minus 1 square gives 1 upon b into in bracket 1 plus bx plus 1 is equal to a plus 2 is equal to c. We write as it is. Now in numerator we cancel plus 1 and minus 1. So the next step will be limit x tends to 0 bx upon b in bracket square root of 1 plus bx plus 1 that equal to a plus 2 and that equal to c. Now here we cancel b from numerator and denominator. So the next step will be limit x tends to 0 x upon square root of 1 plus bx plus 1 equal to a plus 2 equal to c, provided the condition that b not equal to 0. Since we cancel here b from numerator and denominator, so the condition on b should be not equal to 0. Now here we substitute the limit x tends to 0. So we get 0 upon square root of 1 plus b into 0 plus 1 is equal to a plus 2 is equal to c. So this gives now square root of 1 plus b into 0, that gives 1, square root of 1 is 1 and 1 plus 1, so we get 2. So 0 upon 2 is equal to a plus 2 equal to c, provided b not equal to 0. Now 0 divided by 2 gives 0 is equal to a plus 2 is equal to c, provided b not equal to 0. So the next step will be we have a plus 2 equal to 0 and c also equal to 0, provided b not equal to 0. So therefore a equal to minus 2 and c equal to 0, provided b not equal to 0. And finally, hence we get a is equal to minus 2, b not equal to 0 and c equal to 0. So in this way we get the values of a, b and c. So this is a required solution for the given problem. Thank you.